Hello all, welcome. Thank you for coming. I'll try and work out how to use this. That one? So my name's Sarah Carroll and I'm the project manager for the Perth Groundwater Replenishment Stage 2, and I also worked on Stage 1 as a package manager, delivering some of the construction and procurement packages, and I was also involved in the very early days of the trial. So I've been with the Water Corporation since 2008, and a lot of that has been spent in this space. Dr. Stacey Hamilton, she's also one of our treatment specialists in the water quality branch, and she'll give you a bit of a rundown on her history and what she's done in groundwater replenishment as well. And just to kick off, because we're going to talk a little bit about some stats and facts, I just wanted you to make you aware that between myself and Stacey, over our duration on the project, we've consumed 8,254 Tim Tams, 500 cans of Coke, and about 400 bags of hot chips. So that's how we've got ourselves through some of the tougher times. And I'll hand you over to Stacey now. So she's going to talk through some of the technical elements.
So as Sarah said, I am in the water quality branch. I've been involved from the trial days since 2010, 2011. I'm still out there, and I'll still be out there probably post stage 2 being approved as well. So you're now going to get wowed with some science before we go into project things. So I'm not sure how many people have actually seen this graph, but this just basically goes to show how the dams, how much rain we've had into our dams all the way from 1911 to 2017. So for any of those climate change skeptics out there, this is a living proof that we are living in climate change in Perth. So we actually see a drop from the 1970s, again in around the 2000s, and then again in 2010. And just to re-emphasise, when we actually announced GWER Stage 1 was actually our worst inflow into our dams ever. We actually evaporated more out of our dams than we actually put in. So just to put this next graph up, which is a little bit busy, but I'll explain everything. So here's just our inflows again over the same period. That's been our population increase. And you can see our total water supplied. So what you can actually see from that is actually, even with the population increase, our total water supply hasn't gone in the same steady increase. So we have had a lot of water efficiency measures in that time. This just shows you how much of our water's come from the dams over these years. How much is taken from groundwater. So we started to take groundwater a lot more in the 1970s when we had the first drop from the previous graph. Desalination came on board in the early 2000s. So in about 1958, it was about 90% dams, 10% groundwater. 1980s, it's then 68% dams, about 35% groundwater. 2004, it had switched. So we had about 60% groundwater and 30% dams. 2010, we had about 17% desal coming into that mix as well. Our plan in 2020 is to have 9% included in the groundwater replenishment. So how did we get to here? Water Corporation created a document called Water Forever, Whatever the Weather. So this helps in reducing water reuse, developing new sources and increasing water recycling. And it's all for us to have a climate resilient water supply. So why have we chosen groundwater replenishment? GWER could deliver up to 28 billion litres of water, and that's enough to supply 100,000 Perth households. And so we're hoping by 2060, GWER could be 20% of Perth's drinking water supply. So just to give you some key dates on the scheme, we actually began engagement in 2004. In 2006, we undertook wastewater characterisation because we didn't actually know exactly what was in our wastewater catchments at that time. So we were involved in the Premier's Collaborative Research Program from 2006 to 2008. So that was also with the Department of Health, CSIRO, Curtin University, etc., etc. It was a really big project. We made an interagency working group, which at the time was DEC, Department of Water, Department of Health, and we also started characterising our aquifer on the Beanie Up scheme. 2008 we did some baseline groundwater sampling. 2009 we commissioned the advanced water recycling plant for the trial plant. 2010 we commenced recharge of the trial plant and we launched our visitor centre. 2012 we completed the trial. 2013 we actually were able to continue to use that trial plant. Department of Health gave us approval to continue to use it, and we actually had a final groundwater replenishment trial report and government decision. 2014 we decommissioned the Gwert plant and started constructing stage 1. 2016 spent a lot of time commissioning stage 1 and commenced the bore field characterisation, and we also had the announcement of stage 2. 2017 we got approval for stage 1. We reopened our new visitor centre and we started constructing stage 2. 2018-19 we are still constructing stage 2. Going into early next year is when we will start commissioning the plant. So I just want to emphasise this whole process has taken us at least 15 years. We have had people from Cape Town come over and ask us how long it took, because he had 3 months. And I told him it's taken 15 years, so good luck, buddy. So just to re-emphasise why we did the trial, the objectives were, is it technically feasible? So the treatment process we wanted to use, we wanted to know whether or not we could use them. We also needed to develop policy and regulation, and we also had to have the community on board, because there's no point spending so many millions of dollars if the community doesn't want to come along. So the ministerial announcement on stage 1, so the then water minister at the time basically took a swig of water, not at the final compliance point, but close to the final compliance point, but yeah, that's what happens when the media gets involved. So basically his press release was that we would do 14 billion litres, and basically our 3-year trial was a resounding success, and all 62,300 water quality samples met strict health and environmental guidelines. So just to give you a rundown on the treatment process, I could stand up here for hours, but come and find me later. So we actually have a number of critical control points, which are just like checkpoints throughout the system. If the water hasn't met specifications, it goes straight into the ocean outfall, so we don't allow it to go to the next point. So we have 2 critical control points from the wastewater treatment plant before it comes up to a storage tank. So the wastewater flow into the plant is not consistent every 24 hours, so we actually have to balance the water storage. We then have 3 critical control points at the ultrafiltration process, 3 critical control points at the reverse osmosis process. Water coming out of the RO is about pH 5.5. We have to get it up to about 7 before we can recharge. Quickest way to do that is to degas the water and convert the carbon dioxide to calcium carbonate or alkalinity. We then have 3 critical control points at the UV. We then dose a little bit of caustic to get it up to 7 at that point. We then have our final storage point before it is then suitable for recharge. Part of my work that I do out there is to make sure that all of these critical control points are in compliance all the time. Department of Health also get the trends of these each week for every month and sign off at the end of each month. So how do we do a lot of the sampling? We have 166 recycled water quality parameters that we have to measure. Instead of doing them all the time, what we do is we have 17 recycled water quality indicators, and we sample them and at a more frequent than we do the whole 166. So basically each of these indicators represents a different group, and basically if that indicator flags, it means all the chemicals that it's representing under it, we would then go and test from there. So just to give you a rundown on what our indicators are, we have metals, inorganic anions, disinfection byproducts, nitrosamines, miscellaneous organics, pharmaceuticals, pesticides, dioxins, so a whole plethora, because we can't actually go and measure all the millions of chemicals that are out there. So we've taken this approach with Department of Health, which is similar to what they do in Orange County over in America as well. Now we will go back to Sarah.
So just getting on to, we've talked a little bit about the science and sort of what we had to do there. Then we also had to go through a construction phase. So the stage 1 project, which you can see there, was a $125 million project. We employed about 180 people directly on the project. It ran from October 2014 through to October 2016, and then we went through a verification and validation period where we basically needed to prove that the plant was going to do what we said it would do. There was about 450,000 man hours spent on the project, and we procured equipment both locally and from around the world to ensure that we got the best technology that was going to meet our process requirements. Some interesting things for those of you that like construction. There was 2,700 cubic metres of earthworks undertaken, including removing unsuitable material from previous sins of the past on the site. 1,000 cubic metres of concrete was poured. There was 15 kilometres of underground and above ground pipe work just within the buildings. And 70 kilometres of cabling as well was installed. So there's quite a lot of equipment in those small buildings, and quite a lot of effort goes into actually putting them in there. So just some other sort of facts. So what we had to build was a new feedwater pump station that took the water from the wastewater treatment plant up into the main plant. We also constructed a series of recharge bores. So what do we do? Three bores going into the Leederville aquifer, which is the shallower confined aquifer, and then also one into the deeper Yarragadee aquifer. We had in the building we had UFRO, a UF pump building, fine and coarse screens, recycled water pump building, and a chemical storage building constructed. Balancing tanks, recycled water tanks, and flush tanks as well. So just a little bit about the timeline from a construction point of view. So once the Groundwater Replenishment Scheme full scale was announced in 2013, we then went on to a procurement process, which was a competitive alliance between two bidders. During 2014-2015, the GWRT was closed, so that meant the end of the trial period, and we were starting to focus on the full scale. In 2014, the project was granted approval to construct, and two proponents went forward during that period, with the main design being awarded the main procurement partner being awarded at the end of 2014, and that was when the KEP Recharge Alliance was formed. So that was an alliance which was a joint venture between TEAS and CH2M Hill. Construction commenced at the end of 2015 and went all the way through to October 2016. Then during 2016-2017 we started commissioning, and then in July 2017 Department of Health gave us approval to recharge. So that was a fairly significant milestone for the project, and it was one that definitely couldn't have been achieved without all of our different partners that were involved during the construction and commissioning phase. So a couple of things, what makes a project like this successful? So we had to achieve a number of targets during the trial, and we also had to ensure that was continued on during the construction phase and also during commissioning of the main plant. Without any of these elements, we wouldn't have succeeded, and that's what makes this project so important and such a cornerstone. So we had to prove the technical feasibility. We had to prove that what we had designed was going to work and that it was going to produce water to a quality that was, safe for people to eventually drink. And we had to get through policy and regulation. So it was really, really important that we brought our key stakeholders along. We couldn't have done this project without Department of Health. We couldn't have done it without Department of Water, and we couldn't have done it without all our other regulatory bodies actually stepping up and saying, hey, this is a great idea, we get on board. So If we didn't achieve that, we could have all gone home. The other thing was community support. We had 14,000 people come through our visitor centre. We had thousands and thousands of individual meetings with various different government bodies, with agencies, with individuals, to talk about the science, to talk about why this was so important to Western Australia. And that was critical, and that was key to what makes this project so great. And the most important thing is our regulator relationship. All our regulators stepped up, they all supported the idea, and they all got on board. And you know what? They all put some meat in the game. So if we don't have their support, we couldn't have done this. And this project is key, and it's pivotal to the future of Western Australia and the future of how we look at water across Australia. So we're setting the benchmark for the rest of Australia for what you can actually achieve in the water recycling space.